Welcome back everybody to another video lecture from Mrs. Semino. Tonight this is the second part in our atom series. We'll be talking about the parts of an atom and how you can make those atomic calculations. So I'm sure that this is a review, but let's just go over the three main subatomic particles. The first one you have is the proton. We know that it has a positive charge and it's located inside the nucleus. You can see those positive, oops, my little dot's not landing on there, but those P's are your protons in the nucleus here. And it has about 1 AMU. We also have a neutron. It has a neutral charge, so no charge. That's why this zero is here. It's also located in the nucleus, so that's what the little N's in here are representing. And notice this one also has 1 AMU. So your proton and your neutrons are about the same size. Then, like we discussed on the last video, we have electrons, and they are hecka small. So look at their size. And so they don't add any mass when we get to our atomic mass units. So we don't include electrons in that calculation of average atomic mass because they're so very small. And then of course, as you know, they have a negative charge, and these guys are located in the electron cloud, and this is the area that's surrounding the nucleus. So in our last chapter, we talked about how the periodic table is organized according to its properties, and the reason the properties are the way they are is this repeating pattern on there, and that repeating pattern is based off of the number of protons. So the atomic number tells us the number of protons, and for some reason we use this abbreviation of Z here. I guess I should offer up like 5 extra credit points to whoever can figure out why Z is the number that's used for the atomic number and not something like A. But you guys probably are familiar with this again. You know that carbon has 6 protons, so its atomic number is going to be 6. So if you look on the periodic table, the number that you're going to see like in the upper corner there for carbon is going to be 6. Phosphorus, it has 15 protons, so its atomic number is 15. Gold, it has 79 protons, so therefore its atomic number is 79. So the thing that you need to know is that the number of protons never changes. And if you do change the number of protons, you are going to actually change the element that you're looking at. So you guys can see all these have different numbers of protons. So if we went to 7, we'd be talking about nitrogen. If we went to 8, we'd be talking about oxygen. If we went to 9, we would be talking about something else, okay? Like a different element. Also, the other thing you need to know is that the number of protons equals the number of electrons, and I feel like we should write here in neutral atoms. Oops, that's kind of like a big marker right there. So in neutral atoms, I'm kind of writing off the slide, that your number of protons is also going to equal your number of electrons. So on the last slide, we talked about something called an atomic number, and that is the number of protons. Here, we need to talk about the mass number, and oddly, it's represented with an A often. So the mass number is the number of protons plus the number of neutrons. It's always a whole number. This number is not found on the periodic table. It's something that you are going to have to calculate all of the time. I will show you a cheater method that can help you approximate this mass number, but again, it's not found on the periodic table. I hope you remember in the last video we talked about somebody called John Dalton. He was credited with coming up with a modern idea about the atom. We did mention some of his postulates and how we've had to adjust his postulates over time, or his ideas over time. One of his ideas was that all atoms of the same element are completely identical, but we now know that atoms of the same element, meaning atoms with the same number of protons, can actually have different numbers of neutrons and electrons. So on this slide, we'll go ahead and see how mass number can help us figure out which nuclide or which type of atom of the same element that we're talking about, like how is that atom different. So if I said that we had oxygen 18, I could figure out the number of protons, neutrons, and electrons because they gave me the mass number here. When we write the element's name, we put a little hyphen and the number afterwards. This is going to be the mass number. So by looking at the periodic table, I can figure out the number of protons for oxygen is going to be 8. Then remember what we said, the number of protons and the number of electrons are going to be equal in a neutral atom. then we know that the mass number is 18 because that's what's given to us. So what we're going to do is we're going to go take our number of protons. We know that's 8. We're looking for our number of neutrons here. We know the mass number is 18, so we can do a little subtraction and find that the number of neutrons that we have in our nuclide is 10. So go ahead and try it really quick with arsenic and with phosphorus here, and hopefully you're coming out with the same results. So on the last slide, we talked about how we can have these things called nuclides. That means that the number of neutrons in them are slightly different. We can also have atoms of the same element that have different numbers of electrons, and that would be called an ion. Ions are formed when atoms gain or lose electrons, and they develop a charge. The more electrons than protons, you're going to have a negative charge. And so just remember this, that electrons have a negative charge, so if you get more of them, the overall charge is going to be negative. The fewer electrons, so if you were to lose some negative charges, you would have a more positive charge overall. Another way that you can go ahead and calculate this is by using this formula. If you know the charge of the ion, you'll know the number of protons, then you can figure out the number of electrons. So for example, if we had Cl minus, what we could do is we could look on the periodic table. We could see that it has 17 protons. From our thing here, we know it has a -1 charge, so we can figure out that it will end up with 18 electrons because electrons have that negative charge associated with it, while protons have that positive charge. So I like to say it this way: if you take 17 positive plus 18 negative, it's of course going to give you -1, and that's the charge you can see on the ion here. For magnesium, we can do the same thing. We know that magnesium has 12 protons, so it has 12 positive charges, plus, I like to add it here because then the electrons have a negative charge. We don't know what that is yet, but we do know that this is a +2, so this will tell us that we are looking for then 10 negatively charged particles to have the overall equation balance out to +2. So here's a formal definition for isotopes. It says that atoms have the same number of protons but different numbers of neutrons. So does your atomic number change? As I mentioned, no, it still stays the same because your number of protons is staying the same. But your mass number does change because remember, to figure out mass number, that's going to be our number of protons plus our number of neutrons. So of course, if we change this value, our mass number is going to change. This slide will be helpful for when we make these marshmallow models in class. So what we're going to be doing is we're going to be making models of the 3 different isotopes of hydrogen. So the first isotope is called protium. Pro means 1, so that tells you that you're only going to have one thing in the nucleus of that atom. So it has 1 proton, 1 electron, and no neutrons, so that's why our mass number is only going to equal 1, because remember, our mass number is just based off of our number of protons and our number of neutrons, so 1 plus 0 equals 1. On the other hand, our second isotope is called deuterium. Hopefully you've heard like duets, and that means 2. So the idea here is that you're going to have 1 proton, 1 neutron, and so that's where we're getting our value of 2 there. And then finally we have tritium, so tri means 3. So I have 1 proton and 2 neutrons, so you can see that in the nucleus over here, and so that's where we're getting our mass number of 3. So the final thing that I want to talk about tonight are isotopic symbols. So you'll often see things written out as, let me just get a smaller pen here, as for example chlorine, let's see 37, or even as Cl37, but you can also see it written as it is down here, where we have our mass number written up on the top and our atomic number written on the bottom. This symbol is really helpful because you can figure out the number of protons, neutrons, and electrons from this information. We already know that if the atomic number is going to tell us our number of protons, so we can say that we have 17 protons. If the atom is neutral, so there's no charge up here, so we also know that there's going to be 17 electrons. Now remember, the tricky part here is figuring out the number of neutrons. So you can figure out that there's going to be 20 neutrons by going 37 minus 17, and then that gives you a value of 20. And so remember, this is your mass number here, sorry, it's not, the marker's not awesome. This is our number of protons, and so this is going to equal our number of neutrons here. In our next video, we'll learn how to calculate average atomic mass. That is actually the number that you see on the periodic table. You'll see why our mass numbers right now are in whole numbers, but when we talk about average atomic mass, why are they in the decimal form? And then our final video will talk about radioactivity.